Hey, what's going on, guys? In this video we are going to see an example on how to calculate maximum power transfer, and also the question is asking to find the load resistance. Finding the load resistance is easy. All you have to find is the RThevenin, and if you find that one, that's going to be equal to load resistance. Now to find the maximum power transfer, we use this equation, that is 1 over 4 VThevenin square over RThevenin. So we have to find VThevenin and RThevenin to solve this problem. Now to find the VThevenin, what we do is we short circuit the voltage source and also we open the current source, and then we find out the equivalent resistance for this circuit, right? Now let's do that one right here. So here we are going to have a short circuit of this voltage, so this is going to be just straight line, and then we are going to have the 6 ohm resistance, and then we are going to have this 12 ohm resistance, and here we are going to have this 3 ohm, and this current source is going to be open like this. Okay, then we are going to have this 2 ohm resistance, and that's it. Now all you have to do is find the equivalent resistance. Here we have 2 and 3 in series, so that's going to be 2 plus 3, 5 ohm. Okay, so 5 ohm, and here we have 6 ohm and 12 ohm in parallel, so the equivalent resistance is going to be 12 times 6. Okay, let's write this one down. 5 ohm is this one, and the parallel resistance for this one is going to be like the equivalent resistance is going to be 12 times 6 plus 12 times 6 over 12 plus 6, 12 times 6 over 12 plus 6. So 12 times 6 is 72 over 12 plus 6 is going to be 18, so it's going to be 4 ohm. So we are going to have 4 ohm right here, and here we are going to have this 3 ohm. Now these two are in series, so 4 plus 3, the equivalent resistance. Okay, I made a mistake. Okay, let's see. Here we have 3, 2, 12, and 6. Okay, this is 5. Oh, this is actually 5 ohm. 5 ohm, right? I put 3. So this is 5 ohm, and the equivalent resistance is 4. This is 4. 12 times 6 over 12 plus 6. That is 4. 5 plus 4, that's going to be 9. So the 9 ohm is the equivalent resistance. So RThevenin is going to be 9 ohm, and that's going to be the load resistance. Okay, now we found out solved for the load resistance. That's one of our question. Now let's go to the next one. Now we have to find the maximum power transfer. In order to do this one, we need VThevenin, right? Now to find VThevenin, what we can do is we can use mesh analysis technique to figure out the voltages. Okay, let's say if this is V1, let's call this one V2, and if I use mesh analysis here, I1, and let's say this I2, and let's create the equations. So going from minus to plus, voltage rise 12 volt, and going along the current going along the current path, that's going to be voltage drop negative 6 I1, and then this is going through this 12 ohm, that is going to be minus 12 I1, and this is going in the opposite direction. But here I think it's better to take this direction because we have this 2 ampere going in this direction. So if I take current in this direction, everything will be easier. Okay, I take the mesh current in this direction, I2. So from this one we know that I2 is already there, because in this one this is the only current going through this. So I2 is going to be equal to 2 ampere, and let's solve the mesh 2 circuit, like mesh 2. Okay, this is equal to 12 I1, and this is going along this direction. We didn't finish the first one yet, right? So we had to finish the first one first. We stopped at 12 I1, but I2 also going through this resistance. So that's going to be, since this is going along the I1's path, that's going to be also negative 12 I2, and that's going to be equal to 0, right? And now from this one, and we know that I2 is equal to 2 ampere. Now we can plug that one right here. So that will definitely going to make this one easier to solve. So 12 minus 6 minus 12, that's going to be minus 18 I1 minus 12 times 2 is equal to 0, and if we simplify this one, this is going to be minus 24 plus 12, minus 24 plus 12 minus 12, minus 18 I1 is equal to 0. Therefore I1 is going to be equal to 12 over minus 18, and that's going to be minus 2 over 3. Okay, minus 2 over 3 ampere is going to be the current. I1 is going to be minus 2 over 3 ampere. I1 is going to be equal to minus 2 over 3 ampere, and that's our current. I1, I2, and that's it. Now we have found out I1 and I2. Now we have to find out the voltages, right? Now since we don't need this one anymore, I'm going to remove this one, right? Okay, now let's continue this one right here. Okay, here we have 12 voltage, right? 12 voltage, and if we subtract this one, this voltage from this one, that's going to give us V1. And here, since this is going along current direction, we have to subtract that one definitely. And this is going to be 6I1. The voltage is going to be, because V is equal to IR, right? V is equal to IR, 6I1. I1 we found out negative 2 over 3. So this is going to be minus 2 over 3 times 6. And that's going to make this one 2, 4. So negative 4 plus 12, that's going to be 16 voltage. So V1 is 16 voltage. Okay, now V1 is 16 voltage. V2 is going to be, since this current is going opposite direction of this one, we have to add them. So V2 is going to be V1 plus 3 times I2. So 3 times I2, we found out I2 is 2 ampere, right? It's right here, 2 ampere, 2. So I1 is 16 plus 6. So we are getting 22 volt. 22 volt, and that's going to be our VThevenin, because if you notice here we don't have any current flow. So whatever the voltage we have right here, that's going to be the voltage across this one. So that's our VThevenin. VThevenin is going to be 22 voltage. Now we found out VThevenin, RThevenin is there. So now we can go ahead and find our this one, P maximum power transfer, right? That's our main purpose. Now P max is equal to 1 over 4 VThevenin square. VThevenin is 22 square divided by RThevenin is 909, and that's gonna give you 13.4 watts. And that's our final answer. I hope this helps. Thanks for watching.